So how comes zero trust in the AWS, and what is verified access? So verified access is going to help you to improve the security posture of your applications and help you to make a step towards zero trust. Each and every request is going to be verified, evaluated and verified by verified access. And you can have your application hosted in a VPC in a private subnet. There is no access from the internet. There is no NAT gateway. There is no internet gateway deployed. It's entirely private. And then you can have verified access, which is going to implement in the background the connection to your private application. It is going to be available through verified access. You can bound these in security groups. So the security groups, you can control all the inbound and outbound connections between verified access and between your applications. So as you would configure it with any other service, it is very similar. It is going to improve the user experience since they don't have to install, update, and manage their client VPN clients on their computers. There is no infrastructure maintenance from the IT operations side, so you don't need to scale your VPN servers. You don't need to update them, patch them, and configure them. There is a simpler troubleshooting since every application access goes through this central service, which is going to log all the requests if you configure it so. And here you can also check if something is not allowed. You can have a look at the policies. All your integrated applications are going to have a central common policy set, which is going to be in the same language, the same place, of course separated for every application, but in a central place where you can manage these. There are a lot of applications in AWS which you can configure and which are integrated with verified access at the moment, but still this is a very new service. This has just been announced last year, the reInvent, so there are a lot more features coming. So how does verified access look like? The components of verified access, the first one is the verified access instance. This is basically the compute power behind verified access. This is going to be the engine which is going to evaluate the request for you. And then you have the endpoints, verified access endpoints, which are going to represent an application of yours. So if you have 5 applications, then you would have 5 verified access endpoints for these. Then you can create verified access groups, which are going to group together applications that have the same or similar security requirements, because you can define policies on an application level, which in this case is an endpoint, and also on a group level, and this makes it possible to avoid a lot of redundant configuration for all of your applications. The next component here is the access policies, the verified access policies, which are going to define the permissions that are allowed regarding an application or a group. There are the trust providers. The trust providers are going to be used by verified access to establish or to get user or device information. Basically, these can be user or device trust providers, for example, Keycloak, that we are going to see in an example later. And the trust data is going to be the details sent by the trust provider. This is going to be used by verified access, and this is going to be verified against the policies. So let's have a look at the architecture a bit more in detail. So we have the verified access. In the verified access, we have all the created resources. And we also have the VPC, which is set up with a private application. And in this case, it is going to be a Lambda function, but it could be a lot more. The direct target of a verified access endpoint can be a load balancer or an ENI, an elastic network interface. And through a load balancer, you can configure an EKS cluster, Lambda functions, for example, Fargate cluster, EC2 instances or auto-scaling groups, and so on. This is how it's going to look like. Then it comes to the trust providers. A trust provider can be a user or a device type. It's something you need to configure at creation. A user type trust provider can either be IAM's identity center or any third-party identity provider that conforms to the OpenID Connect protocol. So if you have something like Keycloak, which is compatible with OIDC, then you can configure it with verified access. And then you can have device-based trust providers, which can currently be CrowdStrike or Jamf. The trust data is then, when you authenticate to your application, it goes for verification to the verified access. Then the trust data is going to be also forwarded in a JSON Web Token to your application. And this comes very handy because if you remember, for example, in a traditional manner, when you have a VPN server and you have a trusted internal network, you usually connect to the VPN. You have the established tunnel that you can use, and then sometimes you need to re-authenticate to your applications. So since you are on the network, you are granted access to some of the applications, but then still you probably need an authentication. Then you would like to act as a user, not simply as a general access to an application on the network. And this is a re-authentication. So if you consider the VPN connection as a first step, then you do an authentication. In this case, there is a so-called user claim testing, which verified access is going to forward the user data to your application in this JSON Web Token. That's how your application is aware of which user is making this request, and there is no need for re-authentication. Then also you can use the verified access groups for grouping together these applications, and you can have your common rule sets defined on the group level and on an endpoint level. And recently, AWS has just announced that you can configure the web application firewall on verified access instances, so you can also have layer 7 rules defined in a firewall for your verified access instance. And what is the price of this? Currently, there is a monthly charge for verified access, and it is charged on an application level, basically on an endpoint level, which is the representation of an application in verified access. So there is currently in Frankfurt, it is $226 per month if you have an application. And also there is a per gigabyte charge for data processed, which is if you have a data intensive application, you must also calculate with that. And now there is going to be a short demo how verified access works, how can we configure the components that it has, and what logs can you see in the verified access logs, and what you can log from Lambda, for example. So let's have a brief look at the architecture that is going to be in the demo. So there is going to be a simply configured, publicly available Keycloak. This is going to be available on an HTTPS endpoint. There it's behind the load balancer, and there is an EC2 instance having a Docker container with Keycloak and publicly available. Also, we have Keycloak configured in a way that we can test verified access. There are two groups. There is a manager group and there is an engineer group. And in the engineer, there is one user, engineer Emma in this case. And in the manager group, there is manager Mario and not verified Noah. Noah does not have its email verified, so we will have a policy that is going to restrict access based on email verification, and that is what we are going to test with this. And let's have a look at the architecture a bit more in detail, even more detailed architecture. So we are going to have these two policies. One is going to be the email verification check, which I mentioned. It's going to be in the group level. And the other one is going to be on an endpoint level. And this is going to be a group membership check, whether it's a manager or an engineer. So how verified access works, it is connected with the publicly available trust provider that we have seen, Keycloak in this case in the previous slide. And verified access is going to create an ENI within the private subnet, and it's managed by AWS or managed by verified access. And that's how it is going to connect to the private load balancer that we have in front of the application. This VPC does not have any connection to the internet. It's just verified access who creates a connection in the background. And also, all of these security groups are configured in a way that a security group has only an inbound rule which allows the invocation from the verified access security group. And the verified access security group only allows an outbound connection to this ARB security group. And now let's have a look at the policies. So as I mentioned, there are going to be two policies here. The one of them that checks the email verification, and the other one that checks the group membership of the user who is performing the request. These policies are defined in a language called CEDAR, and these are a language that can be used for defining policies in verified permission that I'm going to talk about a bit later as well. So when you have these policies defined, you can set it on a group level and an endpoint level, but you are not required to set both of these. So any of these can be turned off, and both of them can be turned on. And when you have one of them turned on, then it's going to be evaluated. When you have both of them turned on, then both of the checks are going to be evaluated one by one, and both should allow the request, and that is going to be a request that can reach your application. So now let's have a look at the demo itself. In the demo, I am going to log into Keycloak first, which is available on keycloak.serverlessbudapest.com. And I'm going to show you the configuration here. We have two groups. We have engineer group and the manager group. And in engineer, we have engineer Emma configured. And in the manager group, we have manager Mario and not verified Noah. In Keycloak, groups are not forwarded in an authentication in the trust data to the application. You also need to configure a groups attribute. So that is what we have right here. It's a groups client scope, which is configured to have the group membership as a mapper. And we have a client configured for verified access. And here in the client scopes, we have the groups configured as a default scope. Because this is a default scope, this is by default going to be forwarded to the application. There is nothing that you need to configure with verified access in order to get this attribute. So now let's have a look at a sign out and have a look at the application itself, which is app.serverlessbudapest.com. I'm automatically redirected to Keycloak to perform a login. I'm first going to log in with manager Mario. As you can see, we can access the application. So manager Mario has access to the application. The application is very simple. It returns the user who makes the request and the email address of the user. So now I'm going to open the application again. And now I'm going to log in with engineer Emma. Engineer Emma is not going to pass the authorization, so we get an unauthorized error. And I'm going to open the app again. And now I'm going to log in with not verified Noah, who is also going to be authorized. All right, so we have seen how the application works. Now let's have a look at those cookies that are forwarded in the request and how this whole authentication works. So when I go to app.serverlessbudapest.com, I'm going to open up the developer console here to have a detailed look at what's happening in the background. let's do this once more. And we would like to see all the requests. And when we enter to app.serverlessbudapest.com, we are automatically redirected to Keycloak. So we get a 302 redirect, and we are redirected to Keycloak. All right, we perform a login. Let's use Manager Mario in this case. I'm going to clear the history here. Now we can see that we have the backend response from the application, and this is already coming from our backend application. You can see the response is very simple, a few information about the user. So now let's have a look at the cookies set by verified access, because that's how the session is maintained. Now I'm going to I will clear all the cookies here. I go back to the network tab. I also clear history and I perform a refresh. We can see that we are still logged in because we are logged in Keycloak. And when we perform the refresh, there was no verified access cookie, but we were automatically redirected to Keycloak. Keycloak performed the login, and it was and we were redirected back to the application. That's what we can see here in the request history. We can see that we were redirected to Keycloak, and when there was the response from verified access, we can see the application itself. Now I'm going to clear the cookies again, and I will also go to Keycloak and perform a logout from Keycloak. And now I'm going to go to app.serverlessbudapest.com, and now I'm redirected to Keycloak. So when we are logged out from Keycloak and also the verified access is application level session cookies cleared, then we will do a re-authentication. And this is very important because it's different to have an application logout, and it's different to have a Keycloak or identity provider logout. So this is something that we should keep in mind. All right, so let's have a look at AWS. What do we have here? We have a backend Lambda application, a very simple application. This was written in TypeScript, and the compiled JavaScript file is also very simple, so we can have a look at it like this. There are a few things logged to the console, as we will see in CloudWatch. And we can also see here that we are using the library and we are decoding the JSON web token. We can see here that this is the header where this token is forwarded by verified access. All right, so we simply log the decoded JWT token, and we are returning a simple HTML response with the name and the email address of the requester. Now let's have a look at the verified access configuration. First, we have the verified access instance. The verified access instance has a verified access group configured, and it has a trust provider, which is Keycloak going to be. It also has CloudWatch access logging configuration enabled, because we are also going to have a look at the requests that are logged by verified access. And also, these integrations here, this makes it possible to configure web application firewall with a verified access instance. Here we have the trust provider configured. It is a user type trust provider, OIDC trust provider. And we have all the trust provider details configured here, which are basically the required attributes with an OIDC provider. We have the client ID, that is configured in Keycloak. And we also have these two scopes, OpenID and email configured. You must have OpenID here to make this work. And also, if we would not have, when we don't have the default scope configuration in Keycloak that I just shown you, the groups, then you should have here the groups or any other attribute that you would like to get either for verified access for verification or to your application. Now groups is a default scope, so it's automatically forwarded to verified access. Then we have the verified access groups. And for the verified access group created for this demonstration, there is this policy, it is enabled, and there is only one constraint here, the keycloak emailed verified true constraint. And here, the keycloak is the name of the trust provider that we have configured previously. So if we have a look at the trust provider, there is a policy reference name, and the policy reference name is going to be the attribute how you would like to reference to the attributes forwarded by the trust provider. So keycloak forwards an attribute called email verified, and it's a Boolean variable, so we can check if email verified is true. And we have one endpoint associated with this verified access group. And this is the application representation within verified access. So we have a lot of things configured here. We have the application domain name. This is available on HTTPS. So we also have a domain certificate configured here. We have a certificate in AWS's certificate manager. And we also have an endpoint here. And there is also a load balancer in the background. So that's how it's connected. Also, we can see the load balancer details here, the subnet configuration, the protocol, the port, and the load balancer itself. We also have a policy here. This is also enabled. And here we have a group membership check. It is going to check if the requester is within the manager user. That's why Genie cannot access the application. All right, and now let's have a look at CloudWatch. There are two interesting log groups here. One of them is the Lambda, because in the Lambda logs, we are going to see the request details, for example, the event itself. So there are a lot of information here. There is a request context. We can also see the JSON Web Token, which is forwarded. This is the user's claims passing that we have seen in the previous slides. And we can also see here the IP address of the requester and also the private IP address of the ENI, which was created by verified access. We also have the context here. And we also have the decoded JWT token. Here, this is the claims passing, so these are passed by verified access. We have the email verified attribute, which is checked, and we also have a few more attributes. Groups is the other one, which is verified. All right, and for the other one, I'm going to go to Logs Inside, because here I would like to show you what can we see in the verified access's access logs. So if we search for example, filter the message like Mario, I will increase the interval that we are searching a bit here. So when we have a look at the verified access logs, we can see that, for example, the authorization was performed twice because there was an authorization against the group level policy and against another one against the endpoint level policy. So we can see that both of these are allowed. Another very important thing is that we have here the public IP address of verified access, and we also have here the public IP address of the requester. All right, let's have another look at, for example, Noah. Noah is the user whose email address is not verified. So if we check Noah, we can see that for Noah, there were two authorizations, and one of them is allowed, and the other one is denied. All right, so the first one was allowed because it's also a manager, and the other one was denied and because the email address is not verified. We have Emma as well. Emma is not part of the group, which is verified. And in this case, we can only see one single deny. And this is because in verified access, there is a short circuit evaluation logic, which means that if there is a deny, it's not going to perform a check for the other one, for example, for the group or to the policy, to the endpoint policy, because both should be allowed to allow the request to the backend application. All right, so basically that is how verified access works. And now let's continue with verified permissions. Verified permissions is, at the moment of this recording, it is not, it's only publicly available in a preview, so it's not generally available. So we still don't have all the details and how it works, but it's already very promising and it's worth talking about. So verified permission is going to make it possible to have your application's fine-grained access control, fine-grained authorization part offloaded from your application. So you probably came across during application development with the task to implement an authorization layer. You can have different roles like an administrator who is using your application. You can have different types of users based on some kind of roles that you would like to have different access for them in your application. And you need to perform an authorization and check if that role is administrator or manager or something else, and they allow only certain actions. This is something that you need to implement in an application, but you can also use verified permissions for it. Verified permission is going to provide you an evaluation engine. It is going to provide you a place to have your policies, and the details of the policies can be defined by you for your application. You can design the schema of these, and also you can have your own actions that your application can do. You can do this using the CIDR language, and this is an example policy here. So for example, you can check a group membership in this case. Verified permissions also contains the schema definitions, and it has also not only the statement grammar, but also an automated reasoning for it. And this makes it much easier to develop applications with fine-grained authorization, and also it makes one more step towards zero trust.